Hello viewers, soil mechanics is one of the most important subjects for various examinations like GATE, ESE and other PSUs. Now in this video, we are going to learn some 10 important questions that are being asked repetitively in these examinations under the topic Basic Soil Properties. Let's get into it. First question is, which of the following can be determined for both undisturbed and remolded soils? Option A, liquid limit. Option B, plastic limit. Option C, shrinkage limit. Option D, none of these. Refer this diagram, that is states of consistency like Atterberg's limits, and give the correct answer. Think about 10 seconds. So the correct answer is option C, shrinkage limit, because if you see in this diagram itself, you can get the answer. Here, within the shrinkage limit, the volume of soil is not affected, because further decrease in volume of water, or further drying of the soil, the volume of the soil is not affected. So which of the following can be determined for both undisturbed and remodeled soils? It's nothing but the shrinkage limit. And let's see some other important points regarding Atterberg's limits. What are the Atterberg's limits? Liquid limit, plastic limit and shrinkage limit. What is a liquid limit? Liquid limit is nothing but the water content, the minimum water content at which soil has tendency to flow. So this is the liquid limit above which the soil is in liquid state. That means soil has tendency to flow. What is plastic limit? A plastic limit is that water content at which a 3 mm thread of the soil crumbles. So below which the soil become crumble. Will get crumbled when 3 mm thread gets rolled in a smooth surface. What is shrinkage limit? Shrinkage limit is nothing but the water content below which or further decrease in moisture leads to what state? Solid state. And there is no change in volume of soil. So if we extend this line to here, that means this is the volume of voids and this is the volume of soil solids. So this is the solid, this is the void. If we extend this line, we can differentiate what are the volume of voids and what are the volume of solids. So this is all about the Atterberg's limits. Now let's move on to second question. Second question is a numerical answer type question. Just we have to calculate some minimum calculations to get the answer. A natural deposit of loose dry sand of 6 meter thick. So for example, this is a strata 6 meter thick they have given, having unit weight of what 15 kilonewton per meter cube, is compacted. So we are compacting of a loose dry soil, we are compacting by some means, and surface gets settled by 0.5 mm 0.5 meter. So this is the settlement. So now the surface becomes like this. 0.5 meter gets settled due to compaction. Relative density after the compaction is 90%, and dry unit weight in loosest state is 11 kilonewton per meter cube. Calculate the dry unit weight in the densest state. So what are the given data? Given data is 6 meter thickness before compaction, and before compaction unit weight was 15 kilonewton per meter cube, and after compaction it settles by around 0.5 meter, and the relative density after the compaction is 90%. The dry unit weight in loosest state, that is in before compaction, the dry unit was 11 kilonewton per meter cube, and we have to calculate the dry unit weight in densest, that is compacted, well compacted state. Just try for some minutes and give the answer. Your options are option A 16.85 kilonewton per meter cube, option B 17.29, option C 18.36, option D 19.46. Just think for a minute. Timer will be running slowly. This is a simple calculation. We have to use some 3 to 4 formulas like this one. I think you got the answer. The answer is option B, 17.29. Now let's see the calculations, how it is arrived. First part is gamma D is equal to Ws, that is weight of solids divided by volume of soil, gamma D. See, gamma D is not equal to the specific gravity of soil solids. Gamma D is different from different, and it is related to the whole soil. That's why we are using volume of soil. So gamma D is equal to weight of soil solids divided by total volume of soil. That is nothing but 15. They have given unit weight of dry sand before compaction is 15. They have given here. So 15 we have assigned. Total volume is nothing but 6 meter cross. Here we can assume 1 meter and lengthwise 1 meter. Just assume as volume 6 meter cube. Ws is nothing but therefore 15 into 6, 90 kilonewton. After compaction, 0.5 meter gets settled. So 6 minus 0.5 gives 5.5, and we can assume that as 5.5 meter cube because we have assumed length as 1 meter and width as 1 meter. Only the depth varies. And gamma D after the compaction, nothing but weight of the soil solids. Soil solids is constant. Whether it is before compaction or after compaction, the soil solids remain same. Only the voids become expelled out due to compaction. So 90 kilonewton as it is, and uh, volume of total solids becomes 6 minus 0.5, that is 5.5 meter cube. So 90 by 5.5 becomes 16.36 kilonewton per meter cube. And this is another formula to get the relative compaction. So dr is equal to gamma d max, that is maximum dry density which is achieved after compaction, divided by the natural dry density before compaction into gamma d minus gamma d minimum. That is minimum means in the loosest state what is the gamma d, divided by gamma d max minus gamma d minimum is equal to 0.9. 0.9 is something but 90 percentage compaction they have given in the question. By substituting all the known values, we get gamma d max as 17.29 kilonewton per meter cube as the answer. So this is how we have to calculate this type of questions. Now let's move on to third one. Which of the following statements are correct? This is a question of MSQ type. MSQ means multiple select questions. Multiple select answer actually. That means it can have more than one option correct. So this question is all about the type of soils. Option A, peat and muck are organic soils. Option B, indurated clay is a type of clay which does not soften under prolonged wetting. Option C, loam is a combination of gravel and silt. Option D, muram is a gravel mixed with clay. So what are the correct options from these four options? Because this is a MSQ type, multiple select type. So just think about the correct options. Not only the one option is correct, there may be more than one options are correct. So the correct options are option A, peat and muck are organic soils. This is correct. Option B, indurated clay is a type of clay which does not soften under prolonged wetting. This is also correct regarding indurated clay. Actually, this is the definition of indurated clay. Muram is a gravel mixed with clay. So this is a gravel mixed with clay. We call that soil as muram. Now let's see other type of soils like this. What is organic soil? We have seen in the first option, peat and mud are organic soils, and other humus also organic soil. We can call other name as cumulose. Organic soil means it has vegetative matter in it. Warped clay means alternative layers of clay and silt. Whenever there is alternate layers of clay, silt, we call that state as warped clay. Loam is nothing but combination of sand, silt, clay. See, in this C option, we have loam. In that option, sand is replaced by gravel and clay is missing. So that's why combination of sand, that's why that option is incorrect. Loam is nothing but combination of sand, silt, clay in this proportion 40 is to 30 is to 30 in an equilibrium. Bentonite is nothing but a volcanic ash and it contains high amounts of montmorillonite. That's why it has high swelling and shrinkage properties. Laterite soil is nothing but it has iron oxide content. That's why it looks reddish or pinkish in color. So these are about some special types of soil we have seen. Organic soil, warped clay, loam, bentonite, laterite. Now let's move on to fourth question. Fourth question is, a sample of dry soil having specific gravity of 2.74 and having a mass of 133.7 gram is uniformly dispersed in water to form 1000 cubic centimeter of suspension. So a dry soil of having these properties is dispersed in water to form 1000 cc of suspension. Now we have to calculate the density of suspension. The density of suspension immediately after it is prepared will be. Just think about it. It is one of the easiest question. Just we have to use the density, volume and mass relation formulas to get the answer. Option A is 1085 kg per meter cube. Option B 951. Option C 400. Option D 134. What time starts now? So the correct option is 1085 kilogram per meter cube is the right answer. Now let's see the calculation part. They have given the specific gravity of soil solids, that is 2.74. Then the density will be nothing but 2.74 gram per cc. Actually this is density of soil solids. Okay, soil solids, not the soil. 2.74 because density of water is 1 gram per cc. So 2.74 divided by that one gives the 2.74 gram per cc. Volume of soil is 133.7 divided by 2.74 gives the 48 cc. Now the soil is poured in a 1000 ml suspension. Then volume of water will be 1000 minus 48.8. That gives volume of water as 951.2 cc. Then what is the total mass? Mass is nothing but 951.2 plus 133.7. 133.7 is the mass of soil, that is mass of dry soil we are uh, putting into the suspension. So total mass becomes 1085 gram and getting converted to kilogram per meter cube, that is density is nothing but 1085 kilogram per meter cube. So that's all about the calculation. It's one of the simplest one. Now let's move on to fifth question. Which of the following can be used for determination of water content in the field as well as in laboratory? There are many types of laboratory methods that are used to determine water content. And one of the methods can be used in field as well as in laboratory. What is that method? You can refer this diagram also as a clue or hint to give the correct answer. Option A, oven drying method. Option B, rapid moisture meter method. Option C, pygnometer method. Option D, torsion balance method. Your time starts now. Just think about it. Correct option is option B, rapid moisture meter method. And we can call this as calcium carbide method also. And now let's see other important points regarding determination of water content. And first of all, what is water content? It is nothing but the ratio of water is nothing but the ratio of water to weight of water to weight of solids. Weight of water to weight of solids. W can be greater than or equal to 0. That is, water content has no upper bound. It can be greater than or equal to 100 percentage. Sorry, greater than 100 percentage, or we can say greater than or equal to 0. Oven drying method is one of the methods, and it is simplest and most accurate, and it is a laboratory method. Pygnometer method is somewhat quicker than oven drying method, and it is also a lab method. Sand bath method is a field method, and it can be uh, it can be used only in special circumstances because change of loss of structural water will happen. Alcohol method is also a field method, but and it is rapid but less accurate than the other methods, and it should not be used for organic soils because if we use for organic soils it can be flammable too. Torsion balance uses infrared radiation to dry the soil sample, and it is most suitable for soils that quickly absorb moisture after drying. When a soil quickly absorbs moisture, uh, even after drying, we can use this torsion balance method. In torsion balance method, infrared radiation is used to dry soil sample. Radiation method is a field method, in situ method, and some radioactive elements are used to find the moisture content. For example, cobalt 60. So rapid moisture meter method is nothing but the calcium carbide method, like this, and it is put inside this shaker, inside which we put some 4 to 5 grams of soil and shake well with calcium carbide balls, and acetylene gas will get expelled out, and corresponding amount of water content we will get to know. So for example, WR is the acetylene gas evolved, that is converted equivalent to the water content, means the water content will be fetched from like this formula: WR divided by 1 plus WR. So this is the formula to get the water content based on calcium carbide method. So WR is nothing but the percentage of water, that is amount of water present in that soil corresponding to the acetylene gas evolved because of the calcium carbide, and WR divided by 1 plus WR gives the actual water content in the soil. What is water content? Water content is nothing but weight of water or mass of water to the weight of solids or mass of solids. Mass of solid is a constant in a particular soil sample. Now let's move on to sixth question. A soil has specific gravity of soil solids 2.65. Considering zero air voids and term percentage moisture content, the dry density would be. It is a numerical answer type question, and they have given some three data. Soil solid has some specific gravity 2.65, zero air voids, and 10% moisture content. We have to find the dry density. It is it consists of some basic 2 or 3 formulas, mass volume relationships usually. Find the answer. Option A 2056.85 kilogram per meter cube. Option B that 3082.65. Option C 2409.66. Option D 2094.86. Just calculate the basic one and give the right answer. Option D is the right answer, 2094.86. Now let's see the calculation part. So they have given 0 air voids, which means that air percentage air voids is 0, that and therefore saturation will be 1. Degree of saturation is 100%, or we can say 1. SE equal to WG is the basic and most important formula for soil properties. SE equal to WG, and from which we can find the void ratio, that is E is equal to SE divided by E is equal to Wg divided by S. S is 1, W is 10, that is 10 percentage, G is 2.65, from which 0.265 is the void ratio, and gamma D formula is G gamma W divided by 1 plus E. So substituting all those things, we get 2094.86 kilogram per meter cube as the right answer. Here most important thing they have asked is the 0 air voids. Nothing but eta A or percentage air voids is 0 and degree of saturation is 1. It has to be understood that then only we can do the correct calculation. Now let's move on to 7th question. Which of the following statements are correct regarding alien soils? It's a MSQ type, means there are more than one option can be correct. Option A, formed due to transportation by wind. It's a type of residual soil. It has large permeability. It has low density and low compressibility. So what are the correct options? Your time starts now. So the correct options regarding alien soils are A and C. That is, alien soil is formed due to the transportation by wind, and it has large permeability. Now let's see other important points. Alluvial soils are nothing but it is a soil deposited from suspension in running water. So that's why we can find this type of alluvial soils in river. Lacustrine soils are lake deposited ones. Marine deposits are nothing but the seawater. The soil deposited at the seawater. Glacial deposits are nothing but ice. So it is related to ice deposits. Here we can see alien soil as large permeability. And what are the other important points? Alien soils has more uniformly graded soil particles, and it has large permeability and a high compressibility also, and also high permeability. Everything is there. So this is the correct option. These are the correct options. Formed due to transportation by wind, it has large permeability, and other important types of transported soils we have seen. Now let's move on to 8th question. Natural moisture content is 18%. In this question, some data are given. We have to find liquidity index and activity of soil. Natural moisture content 18%. That is WN is given. Liquid limit is given. Plastic limit is given. Percentage clay fraction is also given. So from this, we have to find liquidity index and activity. It is kind of mere substitution to the formula. Option A minus zero point 0.2 and 1.4. Option B plus zero point 0.2 and 1.4. Option C minus 1.2 and 0.714. Option D 1.2 and 0.714. So what is the correct option? It's a mere substitution formula. You have to substitute the correct values in the liquidity index formula and activity of the soil. So the correct option is option A minus zero point 0.2 and 1.4. Let's see the calculation part. So liquidity index can be found by using this formula, that is IL is equal to WN minus WP divided by WL minus WP. What is WL minus WP? It is nothing but plasticity index. Denominator is nothing but the IP value, that is plasticity index, WL minus WP. In the denominator, WN minus WP gives the answer as minus zero point 0.2. An activity formula is ratio of plasticity index to the percentage clay fraction. So that gives the answer as 1.4. Now let's see other indices. First index IL we have seen in this question, liquidity index. What is consistency index? WL minus WN, that is liquid limit minus natural water content divided by IP, or plasticity index is equal to WL minus WP. IT is the toughness index. It is nothing but the ratio of plasticity index to the flow index. ST is the sensitivity. It is the ratio of undisturbed uh, strength of undisturbed soil to the remolded soil. So now let's move on to ninth question. The consistency of a saturated cohesive soil is affected by option A density index, option B coefficient of permeability, option C water content, option D particle soil distribution. So your time starts now. It's a easy question. Consistency of a saturated cohesive soil is affected by. So it is affected by water content. Consistency is nothing but the degree of firmness of soil. So you can see in this diagram, if we say non-sticky one, that does not adheres to the outer environment, or like this in hand. Slightly sticky means the soil particles will get stick to the uh, hand. Very sticky means like this, plastic clay or something. It can be assessed in a qualitative manner, and we can classify as soft, medium firm, stiff, or we can say hard. Relative ease with which soil can be deformed. We can say like this also. Relative ease with which a soil can be deformed, and what it affects or how it can be classified uh, quant quantitatively. It's based on the SPT values. SPT means standard penetration test values. 0 to 2 means this type of soil will be very soft, and 2 to 4 means very soft. Very soft to soft, we cannot use those soil strata for structures, and it can be used only for park or recreational purposes. And we can see the other numbers, 4 to 8 medium, greater than 30 means very hard soil, and it is good for high load bearing structures. Now let's move on to the last question. 10th question. So 10th question is a borrow pit problem. This type of borrow pit problem is asked in many examinations, especially in GATE, ESE, and many other PSUs. It is commonly seen, borrow pit problem. Now let's see this question. A borrow pit soil has a dry density of 17 kilonewton per meter cube. How many cubic meters of the soil will be required to construct an embankment of 100 meter cube volume with a dry density of 16 kilonewton per meter cube? They have given three data. Nothing that is nothing but uh, in borrow pit they have given uh, two. They have given the only one data for borrow pit. Dry density as 17 kilonewton per meter cube. For embankment, they have given two data. Like volume of embankment to be achieved is 100 meter cube with a dry density 16 kilonewton per meter cube. We have to find the volume of borrow pit soil that has to be evacuated so that we can construct this embankment with these properties. Now let's see the options. You have to calculate and give the correct answer. Option A 94, option B 106, option C 100, option D 90. So what is the correct volume of soil that has to be evacuated to construct this embankment? So the correct option is option A 94. 94 meter cube of borrow pit soil will be required to construct embankment of dry density 16 kilonewton per meter cube with 100 meter cube volume. Now let's see the calculation, how it is calculated. There are basic there are two basic relations for this borrow pit embankment problem. One is volume of soil, that is total volume of soil is directly proportional to 1 plus E, and dry density is inversely proportional to the total volume. By using these two relations, we can get the answer for any type of borrow pit problem. By using these two relations, we can get the answer. uh, Here v is equal to 16 by 17 into 100. How it is arrived? Because v1 by v2 is equal to what? For example, say v1 is nothing but volume of borrow pit, v2 is nothing but volume of embankment. So v is inversely proportional to gamma d, we know. Therefore v1 by v2 is nothing but 16 by 17. 16 is nothing but the dry density of embankment to be achieved. 17 kilonewton per meter cube is nothing but the dry density of borrow pit soil. So that's why we have assigned like this 16 by 17. So v1 is equal to 16 by 17 into v2. What is v2 here? Volume of embankment to be achieved, that is given as 100 meter cube. So 16 by 17 into 100 gives answer as 94 meter cube. And another one important relation regarding borrow pit soil is WW is nothing but W suffix W. It is nothing but the weight of water to be added in the embankment to achieve the given dry density. So how it is calculated? WW is equal to gamma D1 into V1 into the difference between two water contents. What are the two water contents? In borrow pit, there will be one water content. In embankment, there will be another water content due to some compaction and remolding, etc. So difference between water content is nothing but the WC1 minus WC2 or anything. So gamma D1 into V1 into this difference gives the answer for weight of water that to be added in the embankment. Or we can use another formula too, gamma D2 into D2 into the difference. Either of these two formulas we can use to get the weight of water to be added. So these are the three important relations in case of borrow pit problem. For any kind of borrow pit problem, we can use these three relations to get the relevant answer. So now we are at the end of this video. We shall see another topic in geotechnical engineering series in the next video. If you like this video, please comment, share and subscribe, and share with your friends too. Thanks. Thank you for watching.